Alright, now question 3. This question is about intermolecular forces, your van der Waals forces, hydrogen bonds, dipole, what's the third one? London dispersion forces as well, right? Now check out the description boxes or told links for other recordings for the question paper. So for now, I spoke to question 3 bafunani. Oh, by the way, this is a two-part question. Kuno 3.1 bese kubana this one 3.2. Azange ngikhona ukuyifita on one slide, so ngisplitile, so qala ngo 3.1 ke. Now 3.1 but the boiling points in the table below were obtained during an investigation carried out to compare the boiling points of group 7 hydrides. So iodine, fluorine, chlorine. Okay, the hydrides. Oh, okay, all right. So hydrides, it's all the compounds between a hydrogen nama halogen gases. Hydrides. I didn't know this. Bengazi ukuthi bawabiza hydrides. Okay, so sino hydrogen chloride sibuye sibe no hydrogen bromine are labeled in the table as compounds A and B respectively. So sinama compounds in this column. In this column sinama compounds, then molecular mass basipha nama boiling points as well. Now yipi, okay, ngiyazi ukuthi anye kungiphendule, but zibuze le question le. Okay, anye kungiphendule ngoba this is a recording, so but zibuze le question le. Between A no B, which of the two has the highest boiling point? Is it A or B? Of course it's B. You know why? Ngoba negative 66 bigger than negative 85, so it means that B has a higher boiling point. Now with 3.1.1, but is it defined the term boiling point? 3.1.1 3.1.1. so lana it's the temperature at which the vapor pressure of a liquid equals atmospheric pressure. Now what's this one? The boiling point. I heard ukuthi amanzi are boiler much quicker over the mountain than on the ground, or let me say at higher level, at higher altitudes amanzi asheshe boil than on the ground. It's because of vapor pressure decrease with altitude. So the higher you go, vapor pressure yenzani decrease. So uma uya phezulu vapor pressure decrease, it means that boiling point yenzani decrease as well. So amanzi asheshe boil at higher altitudes. So I heard. So angaze ngayo ku mountain ngayo kanje ngayo observe leyo nto leyo. All right. So yeah, this is the definition for a boiling point. 3.1.2. In which phase are compounds A and B at 0 degrees and 101 kilopascal of external pressure? So this is then the temperature and pressure. Yeah, STP. At STP, what's going to be the phase of compound A no B? Alright, check it temperature. The temperature is 0 degree Celsius, and at the boiling point it's what? It's negative 66, negative 85 for both compound A and B. So it means that a temperature at STP on these given conditions, it means that temperature is higher than the boiling point. It means what again? lama lokanje lawa lama compound siwathola kuma gas phase, siwathola ku gas phase ngoba sekaboilile and seka change to ilokanje to e gas. Ayo change from a liquid state to e gas. Yes. All right. Yes. 3.1.3. Name the type of intermolecular force that exists between the molecules of compounds A and B due to the polar nature of these molecules. All right. So okay, lana lama compound lawa abu lama hydrides wethu lawa, hydrogen chlorine, hydrogen bromine, lama molecules are linear according to the valence shell electron repulsion something leyo theory le konje bathini mana things the valence, it's the valence shell electron pair repulsion, VSEPR theory, the valence shell electron pair repulsion theory. So tola ama linear molecules and lama molecules lawa ingathini, there's not much polarity between the ends, between the ends of this linear shape molecule. So due to the movement of electrons around lama lokanje, and so these are covalent bonds between hydrogen and chlorine. So due to the movement of electrons between hydrogen and chlorine, hydrogen and bromine, lauma electrons naga move a create a sort of ilokanje, a temporary polarity between lama lokanje, lama molecules. Now then sithola something called a dipole moment, right? So I was with a dipole forces again, right? Umanga besi pega through the lens of VSEPR theory. So the intermolecular forces is what la we A no B ama lokanje ama dipole forces. Yes, ayafana, from the same group bonded to the same atom, which is hydrogen. So we expect to get the abe nama lokanje nama intermolecular forces afanayo. Lagu 3.1.4. Which one of the compounds A or B has stronger London forces? Alright, yeah. This concept yama intermolecular forces next year usazoyithola ku organic chemist, ne? Usazoyithola ku organic chemist. So lena so abiza ama sithini man, ama alkyl halides or ama haloalkanes. They ngathini siwathola on the same homologous series. Ungawari ngaloko, I'm just mentioning ukuthi usazokuthola next year same concept yama intermolecular forces usazoyisebenzisa na next year. So lawa belong in the same group, meaning that ama forces wabo azofana in a way, right? Azofana. So which one of the compounds A or B has stronger London forces? Way-2 nama London forces, but yipi ezoba ne nama London forces are much more higher, right? Okay, we can look at the loganji ama boiling points. We can also look at ama molar masses walama compounds now and draw some conclusion from a little information there. So the one with the highest boiling point, always the one with the highest boiling point, ithatha isikhathi ukuthi boil. It's because of there are much more stronger intermolecular forces. Lama molecules asuke abambene lapha kuleyo compound, asuke abambene. So nakabambene wena now to apply heat la, instead ukuthi break masinyana wona athatha isikhathi ukuthi break. It's because of the intermolecular forces are much more strong. Then on another case, awekho that bonded. Now apply heat lana. What happens? Asheshe ahlukane ngoba there's not enough forces between ama molecules wakho, right? So the higher the boiling point, the stronger the intermolecular forces la, right? Ungayichaza ngale ndlela le ukuthi okay, the one with the higher molecular mass izoba nani, izoba nama intermolecular forces are strong, right? Ungayibheka ngama molar mass, the higher the molar mass, or ngasho ngithi there's a direct proportion relationship between strength of ama intermolecular forces and the boiling point. The higher the boiling point, the higher the stronger the intermolecular forces. There's also a direct proportion relationship between the molecular mass as well as the intermolecular forces. But the comparison le uyenza only if lawo ma compounds wakho belong in the same group. Ama hydrides, so ngoba compare ama hydrides, we can just look at ama boiling points or the molar mass. So ubani on ama stronger London forces, it's definitely compound B. Compound B. Why? It's because of sichaze nge-boiling point because B has a higher boiling point than A. Right? Then with 3.1.5, which compound A or B will have a higher vapor pressure? Give a reason for the answer by referring to the data in the table. So okay. 3.1.5. How do I explain this one again? Alright, the answer like about A. Uyabona the one eyisheshe iboil yiyo ke izoba nani na much more ngathi izoba ne lokanje ne vapor pressure a higher. Bheka ne liquid la inside this bottle. Le bottle leli sealed la lana sinamanzi, or let's say just a liquid. This is a liquid. So in this liquid, uma uyibeka uthatha le liquid, let's say it's H2O liquid yethu. Mhlawumbe I think ukwayi observe somewhere this thing. Le liquid le bhodlela leli nale liquid uma ulithatha ulibeka ulistore mhlambe ekhabetheni for several days, uzothi na uvula le khabethe uthi uchecka le bhodlela uthola ukuthi selijulukile la ngaphezulu. There's sweat around the bhodlela inside. Why? It's because of the vapor. It's because of the vapor. It's because of the vapor pressure. It's because of the vapor. So leo vapor na ifomeka lapha phezulu. It's because of le liquid. It's in a state of okay. Le liquid lena iya change into into a vapor. Ibuyela back to ini liquid. There's something called the equilibrium, but that's more about the topic like grade 12. For now, there's something called the vapor pressure lapha. Vapor pressure above the liquid. So therefore, the liquid or the compound eyisheshe iboil yiyo ke leyo ezolokanje ezobane lokanje ne higher vapor pressure. There's an inverse proportion relationship between vapor pressure and boiling point. The higher the boiling point, less vapor pressure. The lower the boiling point, the higher the vapor pressure. So lana ke compound A is our answer. Explain ke, but give a reason for the answer by referring to the data. It's because compound A has a lower boiling point. This is our answer. This is our answer, like 3.1.5. okay, now asizilana ke manje to this one, 3.1.6. Compound C, hydrogen fluoride, not shown in the table, has a smaller molecular size than both A and B, but has a relatively higher boiling point of 19.5 C. 19.5 degrees Celsius. Explain why the boiling point of compound C is higher than that of compound A and B by referring to the type and strength of intermolecular forces involved. So this hydrogen fluoride, since in a higher boiling point, a very high boiling point, then sesingena ku territorial lokaya ama hydrogen bonds. So the reason why hydrogen fluoride or fluorine, it's hydrogen fluoride une higher boiling point because compound C, compound C has ama hydrogen bonds, has hydrogen bonds, and A and B have siyakhona ukubhala nangesizulu la. Okay, compound C has hydrogen bonds and A and B have, bengifuna ukuthi ama dipole forces, but ngizoqhubeka nayo ngithi A and B have dipole forces, have dipole intermolecular forces, right? Have dipole forces. So all right, since hydrogen bonds are stronger than a dipole, more energy is required to break the bonds in compound C. Right? So there are keywords okwamele wasebenzise. You need to mention the type of forces and the nature of the energy required to break ama bonds or whatever, right? So those are the keywords: energy, now the type of ama intermolecular forces. 3.2 la ku 3.2 but the solid iodine is added to equal volumes of carbon tetrachloride and water in separate test tubes as shown in the diagram below. So now test tube okuqala la kune carbon tetrachloride, lana kunani kunamanzi ke. On both containers test tubes sifaka ini iodine. In which liquid, tetra or amanzi, will the iodine dissolve? You dissolve this thing. 3.2.1 izo dissolve la kulo chlorine, not chlorine man, carbon tetrachloride. Okay, the compound ngizoyibiza ngo tetra ngoba nangilibiza lonke legama ngigcina ngiziluma after u-carbon. So tetra izodissolve la ku-tetra. You know why? This guy unama dipole forces. U-iodine nayo unama dipole forces, right? Dipole forces. So imagine amanzi as this guy, Mr. T, the strongest guy. So strength saka Mr. T si representa amalokanshi lama the strength of intermolecular forces is watwala emanzini, which are the hydrogen bonds are the strongest ones. Then imagine this guy again. I think Suse look for now, just for a moment. Imagine this guy with Dave Chappelle as as the iodine, and the iodine nani in ama dipole forces, right? So iodine, since unama forces are weak, right? The strength sakhe si less compared to saka Mr. T. So uma uzothatha this guy umfaka inside a ring uthi bakomele ba wrestle, it's obvious ukuthi Mr. T uzowina la ngoba i-strength sakhe si much more higher than than Dave Chappelle. So nangabe bayo wrestler labantu laba, it's obvious ukuthi uDave bazomshaya blind. So uDave komele simtholele a compatible companion ozokwazi ukungena naye eringini alwe naye, like, and nakayolwa naye iloka i-strength salomuntu azolwa naye eringini komele sibe fair, almost the same level as iloka i-strength sakhe. Nangu Seth la dipole force naye, so urepresenta ini yena urepresenta the tetra. Dave uyi-iodine, uSeth uyilokanje uyi-tetra again. Since the strengths of the two forces or of the two individuals ayafana, so ku-easy ukuthi iodine adissolve lapha ku-tetra ngoba ama-forces wakhona alingana nama-forces wakhe, uyabona? Alright ke. So lana ke, that's why ngithi u-iodine uzodissolve la ku-tetra. Explain your answer in above by referring to the intermolecular forces. I think sengi-coverile. It's because of u-tetra unama dipole forces, and then ulokanji u-iodine nayo unama dipole forces. So kuba easier ukuthi u-iodine adissolve ku-tetra ngoba amalokanje ama-intermolecular forces are of comparable strength, right? Comparable strength, basically I'm saying ukuthi they have equal strength ama intermolecular forces wakhona ke. So 3.2 uphelela lana, ungayibeka ngamagama wakho nayo le, uyabona? Ungayibeka ngamagama wakho, but just make sure ukuthi uma ureasona you need to hit ama keywords. Kwamele ushayela ama keywords, wafake lama keywords: intermolecular forces, abu dipole, hydrogen bonds, what. But ukubalekile just to mention lama intermolecular forces. Now check out the description box for more content in recording for the question paper. So for now guys, I would like to say thanks. Please like, share and subscribe. So I'll spawn on the next recording. Peace.